KnowThings. We're an internal startup owned by CA Technologies. I'm not going to give away too much of what we do because Menka is going to cover all of that for you in a moment. But really our focus is on helping developers bring their IoT solutions to the market faster and to enable basically continuous integration and continuous delivery in the IoT space.
Actually, he lied a little bit. He's the CEO.
Oops.
He's my boss. All right, hello everyone. My name is Menka Goyal, and I'm the CTO and co-founder of KnowThings. And in this session, we will talk about how KnowThings can help accelerate your IoT business and how our solution can help expedite your development and testing by bringing in continuous integration and continuous delivery possibilities. So my background is pretty much in the enterprise software development area. I was involved in the service virtualization. When it was just a new technology, I was one of the first 4 developers of that technology. And SV is very tightly integrated into CI/CD, and now we're trying to bring that into IoT with KnowThings. So here's the general agenda of the presentation. We'll talk a little bit louder. We'll talk about Internet of Things in general and some of the common continuous integration and continuous delivery methodologies out there and how they cannot be applied to IoT development space. And finally, we will see how KnowThings can help bring it into the IoT space. So all of us around here are very key players into the IoT development and other sorts of things. And we know this space is growing bigger and better every single day. 8.6 billion connected devices right now, and that exceeds the human population on this earth, which stands at 7.6 billion. That's billion with a B. And in about 7 to 10 years, they say there will be about 7 IoT devices for humans, and we have a potential of having more IoT devices on this earth than the number of atoms if you use IPv6 technologies. So these numbers were pretty jaw-dropping for me when I first entered this IoT world. And with the number being so big, the market stands at 1.5 trillion. And that's trillion with a T. And T is for things, and it's good to know your things. So there are so many different technologies and buzzwords in the IoT, different network protocols, data analytics, big data, all sorts of stuff. So with all these different kind of technologies, who do you think is leading the charge? It's the IoT developer. This is my representation of an IoT developer. I'm sort of like one now, and I don't look anything like this, but that's besides the point. What I'm trying to depict here is that all these different technologies are revolving around an IoT developer. He has a lot of power at hand right now, but with a lot of power comes a lot of responsibility. So this IoT developer can really change the future of this industry. This Pied Piper of IoT can lead this industry into the caves of chaos or into the meadows of clarity and standards and tools. But what he needs is the right kind of flute, no, not the tools and standards. And these are greatly missing in the IoT space. So there are lots of buzzwords in enterprise software development, which is where I was for many, many years. Test-driven development, behavior-driven development, continuous integration, agile, just to name a few. The adoption of agile processes has led a lot of emphasis on automating every step of the development and release cycle. Continuous integration and continuous delivery is one standard methodology that brings that automation into the development process. But CI/CD cannot be applied to IoT as it is. And here's some of the reasons why. IoT app development is very much dependent upon the availability of hardware devices. A number of times you need to test your app with not just one, but several hundred or thousands or millions of devices, and they may not be available. And if you purchase them, it's a huge cost factor. Sometimes you're doing your app development while the devices are still in manufacturing. So what do we end up doing? We build some in-house prototypes. And building of those in-house prototypes is another cost factor, time factor, and it may not be very accurate. It may not really accurately mimic the actual device, so you end up having more bugs in the product, so lowering of the software quality. Another challenge is heterogeneous networks and protocols out there. There are so many of them, TCP, IP, Bluetooth, LoRa, 3G, 4G, just to name a few. So to have access to all those heterogeneity environments set up is challenging. So many different protocols, it's very impractical. Now many times, especially in the industrial automation, the IoT apps have to integrate with the existing legacy apps or existing IoT apps, and that could be another challenge. And finally, there are many different data scenarios that need to be tested with your IoT app. Many real and surreal kind of scenarios. For example, if you are building an app for autonomous cars and you have to test your app for a car crash, I'm sure you don't want to crash too many cars for testing this one piece of logic. So traditionally, and I come from this world, service virtualization has helped a lot in removing a lot of constraints in the enterprise world. So what could be those constraints? If your app is dependent upon a mainframe system and you don't have access to that mainframe system, service virtualization has a capability of emulating that component and creating virtual models out of it. And then it brings that virtual model into the development and testing cycles. So it helps a lot in the shift-left test methodologies, which is what is preached these days in the software development world. And it leads to higher productivity. Now, service virtualization, how does it interact in the IoT architecture? So this is like a general depiction of what IoT architecture looks like. It's divided into different tiers. So these are just the pointer words.
Oh, I see it. No, I saw it. It was up here. There you go.
Oh, the TV is reflecting it.
Oh, that's weird.
Anyway, I think we're
You
good.
can't use a pointer on an LCD.
Oh.
So we have the device tier, which interacts with the device gateway. Gateway interacts with devices and it exposes the APIs that other application and services use to get information about the devices. And then monitors and data aggregators, they collect the data from all these IoT devices. Analytics engine, it uses that data and runs data mining processes on top of that and does all sorts of analytics around it. The application and services tier, that's the one that helps in managing the IoT devices. If you have to run some logic with all the data that you have gathered, or you have to respond back to the devices, whatever the logic is required within the application space. And finally, on the other side, there are UI applications that run on web or mobile or desktop apps. They interact with all these different application layers. So these black boxes that show here is where service virtualization can actually intermingle in the IoT space directly. These are the apps and services that are built with well-known transport protocols, industry protocols out there. HTTP, REST, JMS, all these very well-known transport protocols, and there are protocol handlers for these. So it's easier to build a virtual service model for these boxes out there, even for a device gateway, if it runs on a standard protocol. Now the challenge, however, lies when there are devices involved, and even some gateways that are not on the standard protocol, then how do you emulate the behavior of that? So at KnowThings, we have come up with a machine learning algorithm. We call it TIPS. TIPS stand for Things Intelligence Processing System. It interjects between the device and the gateway layer and understands the traffic that flows between the two. And it uses sequence alignment and genome sequencing and other methodologies to understand those messages that are going back and forth and build a virtual model for you without having much prior knowledge of the protocol that is involved. So how does it work? In a traditional virtual service setup, you need a decoder and a protocol handler for every kind of messages that are coming in. These decoders, they split the incoming messages into separate tokens and extracts the fields and values out of it. And then there are certain predefined set of rules that are applied on these fields and values, and then we generate the response that has to go back to the client. So what would be the challenge for that in the IoT space? Again, you have to write a decoder and a transport protocol handler for every kind of protocol that's out there, which is pretty unrealistic. So TIPS has come up with a different approach. TIPS uses sequence alignment and data mining to understand, to analyze the recorded messages. So if there are recorded messages from the network, we understand that, and we come up with a model which is agnostic to all these protocols. We apply Needleman-Wunsch genome sequencing approach. It's pretty popular in the genetic world, all these genome research that is happening in the world. They use that genome sequencing algorithm to identify different gene patterns. And we have been able to leverage that to automatically discover the byte level patterns. So the incoming request and the saved request, and we byte level match those patterns and come up with a response that needs to go back to the client. Yes, sir.
Is TIPS part of KnowThings, or is TIPS some standard algorithm?
It's a part of KnowThings.
Okay.
So we developed it in conjunction with the University of Swinburne out in Australia. So we have a technology partnership. We started this work, 3 years?
4 years.
4 years ago on the first version for the service virtualization enterprise software. And now have continued to advance it really to focus on the IoT space. One of the things we were throwing at mainframes in the past, one of the things we found is it's really smart at doing lots and lots of little messages, not as efficient with really big messages.
Okay, well, I'm going to go back to Eric's question. He asked you if it was a standard, and you said yes.
Oh,
Didn't that what you
I
asked?
did, right.
Oh,
No, I
And
said
you
no.
said yes.
No, I said no.
It's just a feature of
It's just a feature.
Right.
It's the we call our machine learning algorithm TIPS.
That's what I was wondering. I was wondering if TIPS was something that you had incorporated, but it was
It was
like
something
a
we
machine learning
developed.
algorithm.
Yeah, we have developed in-house, but we use the help from the Swinburne University.
So I'm still trying to understand the steps, right? Like, if I send a whole bunch of TCP/IP packets, it automatically detects the TCP/IP protocol? No? Or
Yes, to an extent. In some of the later slides, I'll show you the process that is involved. And one of the middle process, it understands the protocol a little bit, so it can derive the messages out of it. It will be, I think, 2-3 slides further. Yes.
Can I learn more about the virtualization environment? Is this your own proprietary, or are you using some off-the-shelf Amazon or something?
Service virtualization is a product that CA owns. We are CA employees. KnowThings is a part of CA Accelerator initiative, and it's just one of our products that was started
We're
about 10
talking
years
about
ago.
a CA environment, and in that you're developing these.
Yeah, so we are accommodating that into the IoT space.
I think you were asking if this is happening in the cloud in AWS or something like that, right?
No, probably they will be. IBM will have their BlueMix algorithm, Amazon will have their DeepMind, everybody will have their own algorithm, but I want to understand which environment they're working in. And that's it.
Oh, no, a couple more points that I wanted to touch on. So in the traditional virtual service kind of setup, when you're generating a model, you are creating records. So you do that CRUD operation, create, read, update, delete. So the messages are discrete, and the records are either there or not there. So it's relatively simplistic in the traditional enterprise software to create a model out of something. Now, in the IoT, however, there's a continuous nature of data. And that's integral to your testing, right? If you have a temperature sensor, for example, it has a continuous range of values that are determined by controller settings and the environment. So what TIPS does, it understands, it learns that behavior, and then it mimics that by establishing the correlation between those between the controller settings and the sensory values, and then it sets up a test environment for you by continuously sending you that data.
Oh, okay, so it kind of sounds like AI when you say it learns. Yeah, and excuse my voice, I'm kind of have some crud. But so in AI, the way I understand it is you have to train the model to do, whatever, like figure out whether it's TCP/IP or Camel Phase 3 or whatever. There's like a million protocols and standards. So who does the training? I mean, do you guys in-house train these systems to recognize standard stuff? Or does the developer and the person running the test platform or somebody in your external team have to do the training for the model or tips? Or
So it is an in-house development thing. We have certain modules, like a module for TCP/IP, module for Bluetooth, and other technologies, which helps you build the model.
okay,
And then once the model is created, then there is no requirement for a protocol or anything. Then you can just play it back.
okay, so you take what you guys have already built and then add on, because it's kind of like a joke. I've done systems integration. It's like standards are great. Everybody should have their own, because that's the way it really is in real life. Every vendor interprets certain data sets, in a certain way they can. And if you really read the standards, they say you can do that. So I guess that would be up to the individual trying to integrate the system to, change those certain data fields, correct? And would you be able to do that?
There would be some level of configuration required, and as
Okay.
we are building our product, right now it's in the prototype phase, and our MVP is coming in May and June timeframe, and we are adding all these different features. So there will be some level of configuration that you will have to do
Right.
based on your protocol.
Have some controls. Like I said, everybody seems to want to do their own version of a protocol.
So, I just want to add into sort of that, like the pieces that we have to build for those modules are, so I'll usually use the OSI model, right? So for layer 1 or 2, we need to capture a byte stream. Once we have that byte stream, TIPS does everything else for us.
Okay.
So to a certain degree, it's like we talk about TCP/IP, we really care about layer 1 or 2 so that we can get that byte stream. So right with Bluetooth, all of that gets also a little bit complex. But once we can basically take it off of the wire, TIPS figures out everything else for you, and then later we're working on things so that you can add in scenarios that you haven't seen. But it really kind of creates that black box from it, so we don't have to go figure out what your MQTT messages were on top of any of this, or what are the specific protocols, or if you have something that really is like serial, right? Just some dumb bytes over serial. We don't. TIPS doesn't really know it, but it does a very good job of mimicking it.
Okay.
What kind of bit error rates
I'm sorry, I didn't get the question.
Say that right?
Bit error rate.
Bit error rate?
Bit error rates? I don't remember the exact.
The good news is they would just mimic whatever they saw. It's like monkey see, monkey do. They see it, they memorize it, they process it, figure out what the distribution of the different types of messages are, and play it back.
I guess what I'm asking is what percentage?
Does it fail?
It really doesn't matter because whatever bit error rate they're seeing on their models, or in their samples,
Actually,
They're gonna play it
university
back.
has done research on that. When they helped develop this module for us, they did it on several different applications like LDAP, H7, there were some others.
Oh yeah, HL7, CoAP, MQTT.
MQTT, CoAP, and they have a tabular statistical data for us, which says what level of error is involved in each of these technologies, but I don't have that information.
Yeah, we published in the IEEE back in May. I can probably dig up some of the specific figures around some of the results that we had.
Yeah.
So let's also structure this. You're talking about short-range IoT protocols, Zigbee, Bluetooth,
Yes.
where you just talk with layer 1 and layer 2. And most of our guys are, in our mind, we have long-range IoT protocols, and I assume that those are probably you haven't looked at yet, because those will require layer 1, layer 2, a radio interface, layer 3. So we probably are building a model on the intelligence side with short-range IoT. Did I get it right, or did I get it
I
wrong?
think you're.
Because Zigbee, Bluetooth are short-range. They're
Yeah.
not for 2-3 miles
But I
radius.
think it's
No, we don't
not
care about
dependent
the- we
on
don't
the
care about the
range.
range.
It's not
I
dependent
wouldn't
upon the
care why
range.
you care. You just,
Yeah, we don't-
they just insert themselves somewhere in the stream.
Yeah, we just
Where they
said-
can intercept the unencrypted bytes.
But they want to stay away from the question like TCP/IP, which would be something you need to worry about when you get into.
Oh no, our first prototype's focused on TCP/IP that you can grab today. So one, I'm talking about it because I've been working with Adam over here, who is coming out with some really cool products. I'm not going to steal anything, but so that's got my mind on Bluetooth and some of the consumer short range right now.
Short-range.
But we don't care about the range, as long as we have the place we can sit in and intercept that network.
Because it's emulated, that's why you don't care about whatever it is. It's not a real test environment. It's like a pseudo stuff, so you're basically throwing data at it, and then the machine, I guess, will learn. I mean, I guess, that's what I'm visualizing, but I
This
don't
is
know.
very, very interesting. Really appreciate you sharing this with us. Please.
Yeah, I think some of the slides that are upcoming will help explain that.
Are you going to go deep now?
Not very deep.
How deep? Will it be 10 feet deep or 2 feet deep?
We're only going a couple more feet deep, I think.
I just don't want to go dive. It's not deep.
No, we'll keep it light because we are all eating breakfast.
Yeah, breakfast and
Alright, so in essence, it's a three-step process, what we have right now. It's a three-step process: capture, model, and playback. So that's what I was saying. In the capture part, you need some kind of tool like a Wireshark tool to capture a PCAP file for you, for example. Basically, all you need is a real-time network data capture, and it could be a long range or short range that I was.
So you don't care?
No, we don't care, as long as we have a capture with us. Then we run that capture through our modeling agent. And that modeling agent holds some level of that machine learning intelligence that we were talking about to understand the different messages that are in that capture. So from there, it generates a model out, which we call adaptive virtual device, or AVD. So once an AVD is created, finally, we play that AVD back as a separate process. And that AVD can replace the original device that we captured it from, or you can run multiple of those and mimic the behavior of multiple devices. So that's like the simplistic description of what we are doing here. So that genome sequencing algorithm, the Needleman Menka I was talking about, it sits at the playback layer so that we understand the transactions that are going back and forth between the adaptive device, the virtual device, and the actual system. So that's about the three-step process. Also the AVD, once it's generated, once you have captured something and once it's generated, you can tweak it. You can edit it for a few things. For example, observe time. You can scale the time up or down to make that device go slower, to mimic that now this is a slow kind of a device versus a fast kind of device. Like if you have some team in the third world country and the network bandwidth and speed is not that high over there, so you want to collaborate. You want to mimic their environment over here, so tweak your AVD to go slower and test your apps. So that can be done.
So what you're setting up is, what are the success metrics you measure the efficacy of your algorithm with? Meaning you're already alluding to that. Maybe it's not bit iterated, it's something, but how have you measured success for your algorithm?
So one of the ways we have measured is how many times it can accurately find or figure out the response of
So
an
false,
information.
true positives.
True positives, negatives, how many times it cannot come up with the right response. The sequencing of the requests that are coming in, and that kind of
Have you
stuff.
created a benchmark?
We do have a paper written that was published in IEEE. I was the co-author of one of the paper that got published 3 years ago, and AK was an author.
Sorry,
of-
no, I went too deep, so
No, it's
My
okay.
mistake. That's my
I
bad.
just didn't bring that deep data in here for this purpose, but
No, but we love the way you're building it. You're really making it very, very sophisticated. Why did you choose genome sequencing? Why didn't you choose any other algorithm from machine learning?
okay, that's an answer which my university professor can give. But they have been playing around with genome sequencing a lot, and they have worked with other algorithms also. But eventually, the research just narrowed it down to Needleman Wunsch genome sequencing.
Is there a number of devices that you have to sample in order for the algorithm to capture, to be able to determine how many, which is like the device ID? So if you're getting streams and you're getting temperature from a device and you just sampled one device, it wouldn't be able to figure out which is the device ID.
Right.
But I presume then you have some nominal number that you have to sample before it can, like, infer the device ID, or you have to tell it where it is.
Exactly. So one aspect is, for any kind of machine learning and artificial intelligence solutions out there, the bigger the sample of data, the more intelligent it is. If we give it more samples, it's going to predict better. The second aspect, I think that I heard you talk, is if there are a number of devices and we have a capture for a number of devices, how we isolate them is by their IP. So the modeling agent,
Because you know
that is one of the
the
inputs.
TCP/IP
Yes.
protocol.
So that is one of the inputs to our modeling agent. We say, okay, you just isolate the traffic from this particular IP import and hand me over an image.
So
I'm sorry. I'll be fast. I think I got this. I don't know if I got this right or wrong, but I wrote a note that you guys used that genome sequencing because it was good at small messages, or did I misunderstand that?
I think from what I recall from the research, because like we've been working on this for a few years and gone through a couple of iterations. I believe that's more what we found as we started putting in some of the clustering algorithms to basically make it very fast. Right, so there's one challenge of, hey, we can do a lot of fancy learning, but as we're trying to now replicate 1 million transactions, say, in a minute, we were doing some optimization around clustering, and that's where it kind of fell out that, hey, apparently, if you talk about the number of bytes, we actually are a bit more efficient for lots and lots of small messages as opposed to some larger messages. And like I said, some of where we had started with this, with Menka and others, were from mainframe with very large messages, so we got a lot of efficiency there, but in looking at the actual characteristics, we found it works even better for something that looks more like IoT, and that's when we said, let's go make something new.
So that make it fit something. Okay, that's cool. So it was a little bit. Is that why you picked the genome sequence? Well, I guess it was a trial
So that was
and error.
now, right?
Yeah, it was meow too.
So I mean, we fund a chair, postdoc chair out at the University of Swinburne. So from their research, they were looking at it. I mean, in my mind, the best, I have to look at it from the 20,000 foot
Yeah,
level. I
that's
can't do
okay.
the math, but you know what? Sequencing a bunch of bytes is pretty much like sequencing the human genome when you don't know what the patterns are, but we're trying to figure out where your genes are.
Okay.
Well, it's the same thing, except we're figuring out where your messages are.
Right.
So-
Okay. 'Cause- yeah.
Yeah.
So do you have like, as you work more and more, do you have these pre-built modules, like I want to simulate like a gas well, or I want to simulate like an apartment complex sensor. Are you building these modules internally that makes it easier for your users to like, oh, we've done that before, and you're extracting that?
So, well, I think Megan had mentioned, we're currently in a prototype phase, so I think some of the longer term, we are very much looking at that. In terms of how can we create a shareable library of some of these types of devices, as well as say manual creation or the injection of the scenarios that you haven't seen. One issue, especially at the early stages, right, is a lot of times your prototypes are in flight. So there's there can be a lot of changes, right? The first version of the prototype you build, there may be message changes over time. So how much value there is over the long term is a little bit questionable in my mind. What we're trying to focus on is making it that quick and easy to create, so the device has that same life, has a very short life cycle, but is very quick and easy to create. That being said, getting around some of the sharing or community ideas, we are looking at how can we create that library and sort of take it, and sort of do it so, hey, we can go, look, I built this on an SP, or we built, certain types of sensors and other things, and then be able to share that with other folks. Because once we have that AVD, it's a transportable element. But I'm not 100% convinced right now that there are enough standard devices. That's what we're talking about for IoT. It's like,
Chicken problem, right?
yeah.
It's the Wild West.
Yeah.
So,
it's interesting you brought up because we have been discussing that, and we also want to test the waters per se, like you brought it up. And if there are some more people, if there's a demand out there, we can easily package this AVD and create a certain standard template for a device.
So does a person that, I guess, buys your service, do they own their own AVD? I mean, it would seem,
Yes.
okay, yeah. But in the meantime, they're helping to create the big data to make it better. And you guys own that part, right? Like the data,
Yes.
okay.
The
data.
algorithm the application that helps you build that AVD is what we own.
Okay.
And then the application that helps you run that AVD as a process is also something that is a part of our product.
Okay.
So once you buy a product, you get both the modeling agent and the playback agent as a part.
Okay. And can you still edit it or change it as
Yes.
your product changes or something?
Yes, so the first editing I just shared was around the time, the
Uh-huh.
scaling factor. There are other kind of editing you can do. Once an AVD is created, you can add additional data scenarios in it.
But you can't change the protocol or the,
Exactly.
Okay, I got it.
So the data structure and the protocol has to be within the
right,
same
it's going to be
spectrum.
static. Okay, so
Yeah.
then you have to buy a new instance of your AVD.
Right.
Okay.
So for example, if you're, I'm sorry, yes, go ahead.
No, you finish up, I'll do that.
So for example, if you are testing an app where a temperature is deriving some fan to run or an air conditioning to run, and within the capture you don't encounter a scenario where there's a temperature spike, for example, or something. So maybe your app wants to shut down the air conditioning when the temperature spike happens, but you weren't able to capture that within your AVD. You can always edit it and add that spike as a virtual scenario.
Okay,
As
that's
a
cool.
virtual data scenario, another kind of scenario in your AVD, and then the spike happens from the virtual device, but you can actually control one of your actual device. based
Using
on-
the fake data.
Yeah, using the
Or
fake
the
data.
whatever.
Simulated data. Yes.
So let's say I was instantiating a data lake. My apologies, I have bronchitis and my voice is out. So, I know this is hard to do, right? So, I know you're all thrilled because I'm not loud today.
I've never heard you so quiet, man.
So, let's say I'm instantiating a data lake. And above the data lake, I'm hosting maybe 50, 80 applications. Yet the data is coming to a common lake, which is actually coming from the sensors and then porting out via API to the applications. Would I have to instead, say I had 50 applications running, would I have to instantiate 50 instances or one instance of your application?
So you mean to have 50 virtual devices?
So, no, I might have maybe 400,000 devices.
You already have the devices.
I have maybe like maybe 500,000 devices.
Okay,
And the devices port all the data into a common lake.
okay.
And the lake then, based on the positioning of the sensors, ports the data out to the specific application that's relevant to the geolocale and the customer orientation. How would I set that up?
So what's your system under test? That's where I think I'm trying to map,
Right,
right?
that's
Which,
what
which,
I'm-
at which
Hey,
layer?
Kurt, could you help me for a second, because I can't talk.
The thing is, Pete, I think, is that this is for testing.
Okay.
It's not a production.
I
You don't put it
understand
into
that
production.
there'd be a lot of test applications.
I think maybe, Pete, and you could correct me if I'm wrong, I have bronchitis too, but I've been under medication, so to try to get
Oh, I'm
better.
under medication too.
Yeah.
I'm
Yeah.
doing big drugs.
Yeah. Okay, so are you trying to emulate, like, what do they call it, load testing? Or, I mean, I would say if it's a virtual instance of the test, maybe you could make like.
Well, the reason why I wanted that, the testing is because obviously with all the applications, right, we're gonna, I mean, there's a lot of test scenarios.
So are you trying to emulate like, just like a unit test of one app? Or are you trying to emulate like the interaction between several apps, like more like a systems integration or a
Yes.
flow? Okay,
Both.
that's a good question. How
So-
do you emulate a flow, like a flow between, you know, this app is connecting to this app, and if this thing happens, it has to go to this app, if something else happens, then it goes to a different app?
Either event-driven or also the routing of the data, the routing of the data packets themselves as well. Is there a way to do
So
that? in-
routing is not a part of our solution. So what we are doing here, like you were saying, there are several different pieces in your application. So there are certain pieces that can be virtualized using traditional service virtualization, like shown in the black boxes. If you have these kind of layers, you can emulate the behavior of that system using SV. And you can emulate the behavior of devices and some device gateways using KnowThings solution. But that routing aspect is not a part of our solution. If I understand it
I think
correctly.
if I understand it correctly, paraphrasing it, say for example, you have these temperature sensors that basically go and talk to other sensors that basically go and shut down the equipment, for example, right? I think what these guys do is give you a whole bundle of knobs, right? I mean, you basically,
Yes.
and now they give you the power to like turn this knob and let's see what happens over here, right? And that's what you guys do, right?
Right.
Yeah, I mean, it would be, if you're talking about routing, it's dependent upon the underlying.
Yeah, how
network
you
at
do
that
the
point.
device gateway and how do you do the backend, but if you want to make sure that these devices are shutting down, you basically turn this knob over here, it's like, did it shut down or not, right? That's what this enables you to do, right?
The
So
other,
you're just sandboxing.
yeah, I
It's a
mean,
big sandbox.
the other thing to think about, right, is what we call the nearest neighbor in terms of best practices. So if I'm getting you correctly, right, if I'm working at this gateway layer, then I'm probably just doing singletons on the various things. If you're trying to aggregate all of this together, you can't create an AVD at this level that would actually aggregate the 10 devices back behind it. And that all depends on which is your really important system under test. And best practice is, this is my system under test, I should be virtualizing here. You want to virtualize the nearest neighbor. There are cases where as you're doing end-to-end testing, you may want to go over there, but each one of these can be basically a consumption for the upstream. So to those routing issues, no man, we're just going to pretend we're here on the network, so that routing should hopefully still be handled by the network. We're not getting into that. And the other piece, right, just because I know we have a lot of radio folks, we're not helping you do the field testing on the radio strength or other things like that. We're trying to make sure that when you get out to do field testing, that all this crap actually works, rather than finding out, you know, once you're out in the field, you're going, hey, all this stuff we could have caught before, oops, right, because that's where you really have a lot of expense.
All right. I know where you live, okay.
Okay.
Yes, you do.
So back to Pete's question, like if you did have like a routing scenario or a if then else, and depending on, you know, what type of API it grabs, and then just recently I learned about, what was that thing you talked about, Eric, the microservices or something? So now they're built in little tiny microservices. Yeah, I don't know anything about it, but I just learned it the other day. I heard it. But so if you gathered that scenario and it went through all the different paths, but you captured it, you made your AVI right here, it would test that whole scenario? Like,
so, yeah.
Okay. So if you included all those paths and if then else and whatever, jumping around to different software things, but you made your AVI right here in the aggregation data collection, then you would have a virtualized model to test that one path.
I think so, I think.
You think?
Yeah, you are
Yeah.
actually replacing a component within that path.
Oh, it's only for component driven.
Components within that, if the path has
Like a sensor.
channels, and there are different components involved within it, whether it's an application server, or it's a sensor, or it's a gateway, or whatever, you are mimicking the behavior of a component in an architecture.
Okay, not necessarily the software logic or routing
No.
is the
No,
other
explicitly, we're not doing the logic.
Okay.
Yeah.
Okay. More questions?
So,
Yeah, sorry, we took this back.
Too bad we don't ask a lot of questions as a group.
it is wonderful. Okay, let's do it.
Actually, the computer wants you to ask. He asks more questions.
It's not going forward.
Time for one more question.
I have a question that
There's a question.
There's a question in the back.
well, it's probably because I was a little late, so I apologize for arriving late. But just to kind of just holistically make sure I understood, is your financial model, is your commercial value around the testing activities only, or do you have a broader strategy for, or what is your commercial strategy? That's my question.
He's the best person to answer that, but I will attempt an answer.
R&D
So-
organizations usually say I provide the best product, and then marketing comes in and converts it into. So we're talking to R&D type.
So it's free.
The buyer.
Actually, right now it is because we're in prototype phase, so it is actually free right now.
And we're talking to you.
AK, we'll have a conversation next week.
But, yeah, I mean, so I think as we look towards our initial launch, the place we're really looking at initial value is really at the prototyping phase for new deployments. So really in that R&D organization to basically make your developers more productive and also to enable basically better and faster QA at the early stages. As we build out some more of the different technologies, so one, TIPS does everything we need from the protocol perspective, but layer 1 and 2 we've got to handle a little bit, right, just to capture that byte stream. So as we enlarge some of those capabilities, we're going to start looking into also getting more production OT testing when you have to do a big upgrade of all the devices, you have a modernization effort in place, that you can actually do that testing in advance. You know, so that you don't have to worry about, like in my case, my nights and weekends I'm the CTO of my wife's farm, which is like an aquaponics and other setup. So as I build new software, I don't want to kill my fish or kill my plants. So that's sort of what, right now we're looking more at the early prototypes, because you have that challenge of, ooh, I built one prototype, Arrow can't give me all the chips, I mean, we can't find chips, right? So you have
How dare you?
You've been warning me for months, right, that we can't get chips fast enough, right?
Well,
So
it depends on the chips. If you're Vishay, no, it's like 76 weeks, but you know, whatever.
yeah, no, but I mean, that's sort of the thing. You want to wait until manufacturing is done to actually test the rest of your consumption layers. So that's our initial value proposition, is really in that kind of phase. Second, you know, typically what you do is you build a simulation yourself by hand. There's always drift for something you built by hand. Something that was built this way, as soon as I update the code on the device, I can make a new updated model that is actually byte accurate. So that's our initial plan. We have a couple of different expansion thoughts, and really following the lean methodology. So based upon where our customers are taking us and where we see that opportunity is kind of where we're going to go as we get past the initial release.
But may I build on our question and
Yes.
say that the economic question comes in because you're going to go into a world of scale. And all the research, and I wrote a blog on this on my LinkedIn, is IDC says the top 5 virtualization environments are Predix, IBM actually isn't in there, Microsoft, Google, Amazon, those guys.
AK, you're not paying them enough to be in the top 5.
AK, so economic question comes in that if you want to survive in this space, you have to come up with your secret sauce and your differentiator, which is what you're alluding to. What is your secret sauce?
Quite frankly, as we move forward, it is actually, in fact, the machine learning. So if you look at how we have some other players in there, right, we're not really competing against Predix or others. They're using machine learning for very different purposes. We're trying to be the Rosetta Stone for your systems,
So
right?
you're a niche player.
Yes, we absolutely
So
are.
what is your niche?
So our niche is, at least the initial value proposition is in the early stages of software development for IoT.
So your time to market advantage, you're playing
Yes.
with things right away.
Software
and very
quality
practical.
and time to market.
What I'm finding is people are much more concerned about the quality of the launch than time to market at this point in time. You can look at it from a couple of perspectives, but it looks like a lot of folks who are really investing in this space, they're as much concerned about the customer experience, building brand and others for the early IoT, depending on which market you're talking about. So the ability to test in advance and not really something that's broken, I think also the changes in what we're seeing within the security realm, right? People are finally starting to wake up and start to care. So there are also places we can use these virtual devices to do some intrusion detection. We've been finding some interesting use cases there. But the secret sauce is that machine learning. If you want to do this by hand, and we do have a couple of competitors who are doing it, the number of engineers you got to hire to handle 80 different protocols, or the fact that these protocols are not standard and always changing, and as Ed has shown me several times, these things are not consolidating, they're fragmenting even more. So we do look at some of our competitors, and you're stuck creating it by hand. So your developer is spending 30 to 40% of their time writing mocks and stubs and just doing basic stuff just to get basic unit functional and integration testing done. We can shrink that like 80 hours of time to about 5 minutes.
So you don't need any Python script then?
We do not require any. And actually, so this is one of the debates I also have with some customers.
Meaning most IoT jobs like this, first thing they ask you is, do you know Python and how to script it? And that.
You don't need any.
Yeah, no, but I mean, this is a debate, right? So there are capabilities, and you were talking about the business logic, that we actually apply, do that in SV. We would enable customers to build in a little bit of that. But I don't think that's actually very efficient for actually managing a integrated and automated software delivery lifecycle. If you're starting to build in some of that logic, you don't actually know the expected results of your test cases. So while people get very tempted to do it, it doesn't speed you up as much because now you end up with a lot of false positives or false negatives. So I do think dumb recording is the smart way to go, but I always have customers or people who are like, hey, this one scenario, let me get sophisticated. And that takes away from the value of taking 80 hours of mocks and stubs that are not a accurate representation for the quick use the machine learning, create it, it's done. And my time is actually spent working on real code, not the plumbing or test code.
From what I understood is, okay, you guys can emulate the component level, like the hardware level. Like you're saying it's expensive to get hardware, or maybe, you know, it's not available yet. So, and you can correct me if I'm wrong, so what you guys can do is maybe say if I have a component, I don't know what kind of component to say, like maybe a slider, and I don't like this slider, it has some limitations, maybe the voltage or whatever. But I want to emulate using somebody else's slider. It may cost a little bit more, but it has higher voltage thresholds. So I could do that in your software, right? Without actually buying. Could I emulate hardware? That's my question.
No.
Using your stuff? No, I can't emulate.
No, we're emulating
Okay.
the messages between the devices and others. So that was what I was saying about the field testing, is we're trying to make sure you're shaking out everything before you get to field testing. We're not trying to get into that space of like understanding the specific voltage characteristics or other things along those lines. But if you're, say, doing a LoRa deployment, we'll know about the different upstream versus downstream kind of concerns, right? Because that bandwidth is a fixed quantity. And with LoRa being extremely asynchronous, you can test out what are the results. What happens when 50 of these guys wake up at once and want to phone home? Well, LoRa's not going to be happy with you if you start doing something like that.
Okay, so it's not hardware emulation, or you can.
No, it's basically the network layer. To
Okay,
whoever's
okay,
consuming it, that's what they view it as.
Okay.
Were you expecting so many questions?
No, this is good. This is actually very nice. I'm glad it's becoming
likes
interactive
questions,
and
more
you guys are
questions.
getting some value out of it.
They did not
Well,
run,
usually
they did
people
not
in a
run any
presentation, you don't
emulation
get
of the
questions.
number of questions at that particular point in time.
So you're going to give this software to us for free so we can test it with all?
Right now, the prototype is free, and that, exactly, yes. It's currently limited to TCP/IP, and a couple of the really fancy pieces of the machine learning are not exposed with the prototype we have today. But I am very much looking for people to grab it. We've seen accuracy above 99% in everything we tested in the lab. But you know what? In IoT, I can't test everything in the lab. So that's part of the thing, is I want to get it out there. As well as we have done CI/CD in the enterprise for a while. I'm not 100% sure what that looks like in the IoT space. You know, I'll be blunt. I don't know if any of us do. So by getting it out to customers early and letting people play with it, I think we can end up developing these best practices around how do you do test automation. And I'm not talking about the robot spinning your platters. I mean about the actual software layer. How do we do it best? So right now it's free, and I really want people to play with it.
Some hackers in Russia want to get a hold of it.
We do have espionage checking. So
They've already got it.
We have a checks.
I was thinking this would be great for that.
All right, let's go to slide 3.
Alright, so you all heard about the differentiators already. Smart visualization, machine learning is a differentiator. Our algorithm quickly learns new protocols. It doesn't require too much hand-holding. And testing at scale, you can spin up several different devices. So like AK was saying, we have tested our solution in a lab. This is our lab. We have a greenhouse application, and coincidentally, AK owns a farm, and he has a smart greenhouse. So what we did, we tried to emulate that within our lab. How did we do that? A sense hat. Some of you might know the sense hat. We used it with Raspberry Pi, and the temperature and humidity sensors on the sense hat was acting as the sensors inside the greenhouse. And then the LED on that sense hat was acting as a fan in the greenhouse. If you want to run a fan in the greenhouse, if temperature spikes, then we just emulated that. So the way our solution works, we have a device, which is the Sense app. And then we created our own server, and now one of our developers is working on a greenhouse dashboard app, which could be your developer. And that's why you need KnowThings is what I'm trying to get to. PseudoThing is what we call our prototype right now that AK was talking about. It's free to download and try at your end. It's called PseudoThing at the moment. So you insert the PseudoThing within the network traffic layer and you capture the traffic and then model it. It generates the AVD for you by running it through the modeling agent. So once the model is generated, now just before that, if the person is working on a greenhouse dashboard for some app sitting on my server and he wants to show a list of all the sensors, the historical data, the charts and stuff, if I just have 1 or 2 devices, that doesn't look very nice. You know, you don't like to look at a chart with one spike going up. It just has to look nice. So to really nicely test your app, you need multiple devices and multiple components interacting with it. So once an AVD is generated, we can retire the actual device and we can run multiple AVD processes. Our PseudoThing will do that for you, run it through the server, and the dashboard looks beautiful. So that's our demo application that we have built in-house. So you guys are free to use it in your world and give us your feedback how it does for you all. And like AP said, it's on TCP/IP right now, but we are adding more protocols as we go along.
I have a quick question. So all those different pseudo things here on the left, do you plug in individual fake data? Like I'm thinking if you have a bunch of pseudo things and you just like instantiate a bunch of differences of this.
There is only one AVD created,
Okay.
and it is run multiple times.
Okay, but you can feed it different data because if it has the same.
AVD is the data.
So
AVD is the
You
data.
can, I think I get your point. Yeah, he's right. AVD is the data, but you can create a copy of that data, make changes to one AVD,
Right.
and keep the other one as it is.
Right,
And
'cause
make
if-
other changes to the third one, and
Right.
then bombard it with different kinds of
Right,
data.
because if not, your chart would be like one thick line or something that would be the same. So that's what I was thinking in my head.
And one of the pieces that we haven't exposed in the prototype right now, I've got to keep some stuff of value for when we release, is we can generate entirely new data scenarios.
Oh, that's cool. So you don't
So-
have to do it yourself.
No, so like
You can make like a little equation, which is usually what
Yes.
you do.
So one of the things I like to is the car scenario, right? So if you're looking at a smart car and you're watching velocity.
Uh-huh.
Well, we'll learn over time. Guess what? It never goes from 0 to 70 in 1 second, but it can go from 70 to 0 in like about 1/10 of a second, right?
Right.
It can speed up that. So we can now create new scenarios that were not exactly like you've seen before,
Uh-huh.
but will adhere to these sort of basic underlying physical model
Right,
things.
right.
And that is not exposed in the prototype. When we go to MVP, we're going to turn that chunk of code on. So that's where another bit of the value, like I looked to where, I think it was Google, was paying guys to ride around their smart car in bicycles, because bicycles are extremely challenging for the detection, right? They move smooth like a car, but they don't move very fast and they don't have enough mass. So they were literally just paying people, like, just keep riding around so we can gain that data. So we can capture, if we take a capture of 1 or 2 days, we can now generate months of that same data that are variations on what we've seen.
Okay, so I can insert fake data pretty easily to,
No,
make
it's
the
supposed to
graphics.
generate the fake data for you.
Oh, that's way cool.
So it's now
Just
beginning to...
given the limitations of the system. Okay, that's cool.
Let's
So I don't
stick
have
with
to do
pseudo
anything.
data, not fake data.
Yeah.
Yes.
Okay, whatever.
Enough things.
And,
What about fake news?
Yeah, exactly.
So I have a lot of history
That's
working
why
with
they stay with
Siemens.
students.
So one of the things I'm really excited about is also as we talk about medical devices, right? You have to be concerned even in your test environment whether you have personally identifiable data.
Right.
So, but we could take say blood pressure monitor data and other things from a real human being and now recreate the profile that's very much like them. Right, so you would have somebody who's got the same type of condition, but it's not actually a real human being's data. So this gets you around some of the HIPAA or other types of concerns.
Don't say it that way. Don't say get you around.
It eliminates the concerns of having real,
Excellent.
personally
Yes.
identifiable
Not a
data,
marketing.
because these are now fake people. Pseudo people. Yes.
So one of the challenges with any method of developing, whatever the process is for creating pseudodata, is that you end up in situations where the relationships between what would normally be seen as independent that matters. So for example, in your example here, we got the 3 pseudo temperature sensors, right? They've all taken some data from a temperature sensor, so they think they're pretty good at modeling what temperature can do. It doesn't go from 80 degrees to 3 degrees to 85 degrees. It's got some kind of pattern to it. Great. But the problem is, now you've got 3 independent streams of pseudo data, except that they're all measuring, theoretically, temperature in a greenhouse. Well, that one's not going to be 35 degrees while that one's 110 degrees. Yet the 2 streams could independently decide that that was a legitimate data source. So I'm curious, have you done anything with aggregations or fleets of these AVDs so that they have relationships to each other that make sense?
So that was the most recent paper published by Zanab, who's the current postdoc working there, where we are looking at basically, we model it more as dependent and independent variables, right? We don't like,
Right.
it doesn't matter whether it's a device or what the container
Understood,
is.
but the variable dependency is the big deal.
So I think what we've got, so yes, we've done some of the basic research. We can do it for a few variables. Some of this is how far does that scale, because that does increase a lot of the complexity at the modeling time. I think it's unfortunately it's seemingly proving to be more of an NP complete problem. So every single variable is now going up in polynomial time, but we were able to do shortcuts on
It may be a
clustering.
losing battle, actually.
Oh, we're not convinced yet. Okay, so that
Work is in progress.
yeah.
Work is in
All right.
And that's one of the areas that we're trying to advance the state of the art in terms of some of that interaction and how far can we go. So we know we can do it at a basic level, but right now I don't want to make promises as to how well that's going to turn out. Some of this is pretty fundamental.
In a traditional sense, where you would be basically, as you said earlier, spending engineering time to develop an algorithm that would simulate a particular environment, okay? It's incredibly time consuming because there's so many dependencies, and even with 15 or 20 sensors, I mean, that's a huge engineering project to get that right. So, I mean, if you could crack that nut, that'd be a great thing, but it's a hard problem.
We're headed that way.
Okay, great.
So as you emulate these things, are you thinking about, I mean, maybe you don't have to think about it because it's only tests, but what do you think about cybersecurity as a function in all of this? Given you've got encryption, you've got different techniques for ensuring security, how do you account for that?
Interesting you brought it up. You want to take that security thing?
Okay, so right now, our specific view on it is really in that we need to be able to grab the byte stream. So we're playing along with that. However,
You're assuming it's secure.
Unencrypted bytes, right?
Well,
in the prototype.
It's a clean
Well,
stream.
and decrypted wouldn't make, it would just be gibberish.
So no, what we are doing, our machine learning algorithm, we have a transformation logic that can hook into it. So you can write your own transformations, which could be encryption, decryption kind of transformation, or any other in-house, your own proprietary kind of logic, which requires you to do some special transformation on the data. So you should be able to add hooks into this machine learning algorithm to do that.
Sure, but ultimately, your algorithm has to have unencrypted data.
right now it does. There's some interesting research going on doing, without deciphering, actually doing transformations on ciphertext. So that's probably a couple years down the line, but we've actually been looking into some of that. IBM's doing some work on basically, can we do manipulations on still the ciphertext? And since basically that's sort of what we're doing, I'm kind of hopeful that may play out, but that is not our focus right now. Instead, we're trying to do the quick hook in so that we can play along with that. But the longer term security concerns, I'm talking with some folks, they're like, this might be good for intrusion detection and that we can basically create attack vectors, right? So we could pretend to be 100,000 Samsung TVs that a bunch of people threw backdoors in and mess with you. Second, because we're sitting at that network layer, we might be able to detect issues that may come from unknown firmware, or you got this built by your company from XYZ, you don't really know what they put in there. We should be able to detect whether some of these phone home or other backdoors are actually there as sort of accidental, low-hanging fruit use cases, but I'm a developer at heart. My big focus is on speeding up life for developers right now. So we have some view on doing some of those as we move forward, but that's post-MVP, probably a year down the line to develop a more security-focused business. We're an enabling technology for security testing. We're not going to try to tackle that.
So what's our value proposition? I think we have talked a lot about it, so I don't need to go into the details, but we let you do advanced prototyping, create realistic data scenarios, and release with confidence. Because if you're if during the development cycle you have the confidence that you've tested in a production-like environment, you can really release it confidence. Less bugs and more customer confidence.
What are you gonna do?
So, one last thought.
Last slide.
This is, no, last thought.
Last thought.
Don't give
There are
people
more
the
slides
chance to
and no
ask a
more
question,
thoughts?
It's Friday, man, no more thoughts.
You can just brush it off, it's 9 o'clock, you can leave. But I had it written down, that's how I have to speak. IoT world is growing, and IoT development is challenging. IoT developers need the standards and tools to make it better for them. And that's where we join hands with you. So KnowThings is your solution for that. And I think we have done this a lot.
Oh, that was a mistake.
I just want to know what you're wrong. Should have put that at the beginning.
Before we get into this,
Kale, ice cream, kind of things I can tell you for the previous point, that sounds like older.
Awesome. I want to thank you guys. Let's give another round.